Hello everyone. Today we will see low pass filter designing of order 40 with cutoff frequency 0.3 and sampling frequency 4000 Hz. So first we will clear our command window, and for that we will use these commands, which are clear, CLC and close all. Then our next step is defining the order of our design, which is 40. Next we will use NPT command. The NPT means these are the number of points used to calculate the frequency response. So here NPT is 1024. This NPT number is always in the power of 2. So therefore such as 2, 4, 8, 16. Then next we will define Fs, which is our sampling frequency of 4000 Hz. Next is defining omega n as our cutoff frequency, which is 0.3. Next we actually design our filter by using FR1 window command. So the parameters are our order of frequency, omega n, which is our cutoff frequency, the name of our filter, and next which filter window we are using. So now I am using the humming window. So I am writing here humming and the syntax of it. So now the next step is h comma f. So suppose h is complex frequency response and f is frequency vector. So this is useful for calculate the magnitude of our filter, low pass filter. H comma f freq z. So freq z computes the frequency response of the filter, and the parameters are b2, which we have here defined. This next parameter is 1, which is feedback. This filter have the unity feedback. Then next NPT and our sampling frequency. Now we have to define the Nyquist frequency, which is always cutoff frequency into Fs by 2, which is sampling frequency by 2. Now we will plot this by using command figure. So here with this, with these parameters, name of our filter, which is FR low pass filter. Next we plot the graph. Here the parameters of our frequency, which is our sampling frequency. Our next parameter is absolute h, that is the magnitude of our window. Then we are using line width. Line width Next we will give the title to our graph. So title is low pass filter, frequency response of low pass filter. Low pass filter. Next we will give X label. We are plotting frequency in our X axis, which is in hertz, and magnitude of frequency response on Y axis, which is our Y label. Then next we'll use X line, which is used for drawing of vertical dashed line at the cutoff frequency. FC. Then the syntax of the X line, which is of K. And next the name, which is the cutoff. So here our filter designing is done. We will run the program. To add the grid on. Add here R. So this is the frequency response of our low pass filter. So here the Hamming windows magnitude, and this is frequency in hertz. Now she is explained about the low pass FIR filter, and I am explained about the high pass FIR filter of order 40 and cutoff frequency of 0.4 pi. Now we clear the previous data by using clear, CLC and close all command. Here our filter order is 40, so here we define the n is equals to 40 and the normalizer cutoff frequency of 0.4. Now we create one variable which name is B to design the high pass FIR filter. Here FIR1 command is used to design the filter FIR1. N is our order, then normalizer cutoff frequency, and high, here high denotes the high pass filter, uh, high pass filter, and Hamming, here we design the filter using the Hamming window. So Hamming n plus 1 is used. Now the NPT is the number of frequency plots, which is in the form of 2 raised to form 1024. Now we design the frequency response. So freqz command is used to calculate the frequency response. That is equals to set. B is our already defined variable, and 1 is the number of feedbacks. So here feedback is 1, so we used 1, and NPT is the number of frequency plot. uh, then we plot the impulse response. For plotting impulse response, uh, figure we use the command uh, figure name of our filter is high pass, so we give the name high pass FIR filter. High pass FIR filter, and high pass FIR filter of color color is the background color. Here we use the white background color. Now subplot second row and first column in figure 1, second row, first column in figure 1. uh, Here stem function is used. Stem 0s to 1, 0s to n, comma b is our high pass filter, and filled be filled uh, and grid on. Stem, then title, we give the title high pass impulse response. Filter response and use x axis label n, and on the y axis h of n. Here we plotted the impulse response. Now we plotting the frequency response of the filter. So frequency response means magnitude response. So plotting the magnitude response, we use subplot 2 1 2. Now we plotting second row, first column and second figure. Plot pi comma absolute of a h, capital H, comma line width line width and line width comma 1.5 grid on enter. We give the title of high pass FIL filter. Filter frequency response. Frequency response. Frequency response. And on the x-axis, x label is used to name the x-axis, x label. In x label, normalize the frequency 0.4 label. Normalize the frequency y label h of h of e raised to h of e raised to j omega, e raised to j by omega, to j by omega, e raised to j by omega.